Hi guys, it's Shaw from STK. Listen, today's I guess one of those days that you look on. It was like when Southern Cross hit that big pay dirt of gold, where the share price just started to rocket. As you know, Aegros has just done a restructure over the last 12 months. They've been building the facility over the last couple of months, and things are starting to really progress. And today, I can't believe I'm going to tell you this, but I'm delighted to say that the machine has been switched on. We're not in the building mode anymore. This thing has been built. The facility, I've done a tour of it today with Damian Thornton, which I'm going to go through the footage. I've interviewed him whilst I was there. The machine is on. We'll be putting plasma through it in the next 2 weeks or so. And the reality is what we've been dreaming about, what we envisioned, what we've worked so hard for at STK with our partners. And I've got to thank every single one of you, and you know who you are. And particularly shareholders have been very patient. This is one of those moments in life where, oh my God, it's actually real. And it is real. This is kit which is custom made and one of the only kind of operations in the world. As you know, nothing's changed since World War II until today. We've got the machine turned on. We went from a V1, which was one cylinder, then we had the V2, which we had GMP for clinical trials, which was a V2, and now we've gone to a V8 supercar. This thing's been switched on, it is getting configured to work. So it's a process will take several weeks to start fractionating plasma. Now, the beautiful part is that all the money that we've invested is now working towards commercialization. We've just seen the EQR quarterly come out. That mine is now progressing to the high grade. You can see what happens to the share price there. It's gone up 10 times virtually, or maybe 8 or 9 now from where we invested at. We're trying to see something similar to Aegros. We put in that money previously, then we had to restructure lower, but now is what we invested for. We'll have the TGA go out there in about 11 weeks' time to get GMP for the facility, or to audit it. So this is the coming to God moment where we've got the facility finally powering up. We've spoke to the head of engineering as well today. She gives a rundown of how they're checking the different processes. There's new software that makes, I guess, the Apple CarPlay speak to the car. That's all been upgraded, rejigged. There's an update on the membranes where we have a look at the, I guess, the fast tracking and the automation of the processing of the membranes. It's huge news today. Huge, huge, huge. And I'm a very significant shareholder, just like my team. We've invested a lot of our own personal money into this. I think we're almost one of the biggest investors. We've got a lot of shares in it, like yourselves do, and we are invested with you. We only make money on this one if you make money, and that's how our Ketos works. It's Southern Cross EQR. We've made a lot of money from these shares, and hopefully this will be our third one, will be the trifecta to get $1 billion valuation when this comes online onto the ASX. And we're not there yet, but this milestone today of turning the machine on is an approaching revenue moment. We're at a low part of the cost curve. We're in a market where there's not enough product, and virtually the technology hasn't been changed since World War II, 90 years. This is the moment. So obviously we'll be updating you over the coming months or weeks as it progresses to fractionating plasma, but there'll be a lot of testing, there'll be a lot of bags or the plasma bags going to potential third parties who'll be toll manufacturing for. This is the moment where everything starts to work from a commercialization aspect. The build virtually is complete, and we've now turned it on. So what we'll see now is my interview with Damian Thornton. We went through the facility today to give you a first-hand look, and seeing it for yourself. Seeing is believing, and I'm very excited to say today I got to see the machine turned on. And here you go. I hope you enjoy it. Thank you.
System, which is the first guy here, basically is the feed stream for the WFI system. So ultimately what we're doing now is we've got a multi-effect distillation still, which gives us the water quality that we need to go into. This is our 5 cubic meter WFI storage tank, and actually this panel here, and this panel here is showing you all of our distribution networks. So you can see here, this is the WFI overview. So that's the tank you see here, DF003. So basically then it then circulates, if we go again to here, then this is actually the distribution network that's feeding all of the individual rooms in the manufacturing process. Okay? So the distribution is from above. We basically have above the clean room ceiling, we have all of our distribution network, which is basically what we're seeing here. Okay, and then this is showing you what the temperature is at each of the actual individual user points. Okay.
So Damian, this is feeding into the system.
The purified water, same thing. So we take the town's water from basically the city. We put it through the purified water system that you see here, and that's basically this one panel is here. This is actually showing you this is the graphic panel associated with the purified water system. So we basically go through a primary filter, then we go through a reverse osmosis, and then we go through electrodeionization. That then brings it to a water quality that we use then to feed into the WFI storage and distribution network. So the generator is fed from here, and then any additional, this has got a capacity of about 1,100 liters per hour. The generator of the WFI has got about 700 liters per hour. The extra capacity then is used for clean in place CIP. Okay. Obviously, as you can see now, these systems are operational. And ultimately, you know, this is one of the big differences between ourselves and the Grifols and the CSLs of this world, is that we are 100% aqueous based. We don't use any solvents in the manufacturing process at all.
So obviously when we're in full operation, this door will be completely closed, because basically, remember I talked to you about we go from pre-viral to post-viral. So post-viral obviously is when we've taken the virus out. So we have our viral filtration happening in here, which is the last step in the if you like, the pre-viral manufacturing process. So from the fractionator, from the Hemoph, we just go through the viral filter, and then we go into the final formulation room that you saw that we were in.
Yep.
So that's basically it. So this should be the Hemoph.
So this is going to be the money shot which we've all invested in. This is where we're walking to now. This is the piece of resistance.
Hemoph, as you can see here, this is our mimic panel. So this basically shows you the actual process itself. Christina's the head of our process development team, which is also basically the package owner for the Hemoph itself.
So we're actually in a phase where we've installed the equipment. We've also, as you can see, we are also have the cooling buffer tank that is on. Right now, we actually have to commission and qualify the equipment, and this is the activities that we're doing right now. This is so that we can get the equipment to then be able to do the fractionation run and separate the proteins out for us. So right now I know you're seeing the engineers are working on this one, but we do have a lot of testing. Yeah. So we have a lot of testing that is actually ongoing right now before this equipment will be ready for TGA to do the audit. So this is the software for the machine. It will actually bring you through a whole series of checks before you can actually go into production. If you look at the system here, these are the 3 streams that we have. This is the feed stream, that is the plasma.
And it says we've got an error because everyone's going to look at that and say...
yeah, because it's 0 at the moment now. So when we're doing testing, you're going to see all this happening because we are trying to make sure that this equipment will function and operate 100%, and also as accurately as what we need to do. In this case, this means that we have to do failure test modes and other things that needs to be in place to make sure that when this equipment is operating, it will be able to handle any of the situations that may come up in a production run, typically. Yeah. So as part of, in order for TGA to allow us to use this equipment, this also means that we not only have to ensure that this machine runs, we also have to ensure that all the interlocks, the failures and all that comes into place, that is set on this machine, they actually work perfectly, and so we actually have to test failure modes. So this is what you're seeing. and what the engineers are doing as well.
Okay, so
Yep.
so where we're sitting today, this, if we can have a look down there, is the hemoph. We've been working for years to get to this point, and as you can see at the top, it's all connected to the water purification, where that comes from what we saw previously. We are finally at this golden stage where we're at the commissioning stage, and Damian mentioned just before we'll be having plasma go through this in the coming weeks. How is that envisaged to run?
So we'll be starting engineering runs. So once we've exhaustively tested this equipment to make sure that there's absolutely no errors, we'll be starting engineering runs. This is where we will start to put plasma through and actually bring it through an actual run. As we all know, the plasma is a very valuable, expensive raw material. Yeah. This is also the reason why this machine needs to be exhaustively tested so that we don't have any errors. This machine is a customized equipment, one of its kind. That means we cannot rely on the usual testing methods that every other equipment goes through.
Okay, so realistically, we've turned it on. We're now testing. Have there been any epic failures so far, or is everything going as you would have assumed?
So right now, you're going to find with customized equipment, right, that nothing works from first go. This is expected, and also the reason why we are testing all sorts of scenarios to make sure that this equipment does not fail when we actually go into a production run.
Fantastic.
Yeah.
So
we actually have, the reason that we're having to do additional testing is that we've just put in a new CPU because when we were doing the initial testing we found some bugs in the process, so we then had to go and get the software amended and changed. So then what we did is we spent the last week doing software testing, and now obviously we've put the new CPU in, and that's why now we're doing the physical testing of the plant. So the first time when we ran it, we found some issues, which Christina says is not unusual. And so basically we then had to go and get modifications done to the actual software itself, so that those errors that we detected during the initial commissioning phase have been rectified, and now we're doing the retesting.
this is just like CarPlay in your car. There's a few hiccups that you've got to
Correct.
fix.
Yeah. So I mean, you have to remember that this process is fully automated when it runs.
Yeah.
Right. So there is a fairly sophisticated software program that's actually driving us in all the conditions. You know, we've got a priming condition. We then have our cartridge integrity testing.
We have production as
Then
well.
after production, then we have clean in place CIP, and the CIP is the cycle that we're going to retest now. In the next.
I'm hopefully in the next half an hour, but let's and that's what we're actually working on, so that the cycle sequence works properly, and that's what the engineers are hard at work at right now.
Yeah, so if you go here, Sean, you'll see that what we've got the cartridges in, right? So these are not the manufacturing cartridges; these are our cleaning cartridges, right? So ultimately, once we do the manufacturing process itself, this is one of only 2 places in the whole plant that we actually have to do a clean in place, because as you know, our basis of design here is multi-product, multi-purpose rapid changeover. So ultimately, at the end of a batch run, we then have to do a clean in place cycle, which is where we're basically using the cooling buffer tank as our CIP storage tank. Let me get out of your way. So the reason the guys that you're seeing, the engineers here, is that when we did this testing this morning, these valves failed. You see them in orange? They should all be green.
So you've got the green ones here, and this is the key thing that we want to show
Correct.
people. This is now in operation. The V2 that have been used successfully for the clinical trials has now become a V8, where you've got the 8 cartridges and it's all starting to get hooked up. And you can see here, you've got the light switched on. You've got the light switched on here. Everything's actually been turned on and we're moving forwards. You've got the reading outtakes here as well. Everything has been switched on and we're now moving to the next phase of commissioning and getting plasma through these pipes, which, thank God we're here. Congratulations, Damian. Thank you very much.
Yeah, so ultimately in the CIP cycle, as I say, we use the cooling buffer tank as our waste tank. And then that's why you'll see each of these is connected to each of our 3 pumps, which you see over here. And as I say, when we went to do the run this morning, these valves failed, which is why we got the engineers back in. Okay?
Yeah, but this is just teething issues. I
Yeah,
mean,
no, absolutely. This will be, as Christina said, we'll have this fixed in the next 15, 20 minutes, and then we'll have CIP cycle running basically in the next 30 minutes at the latest. Because let's say the primary one feeding the cooling buffer tank, which is the pump, which is the big one, and then these are our feed pump and our product pump. So these are all rotary vane pumps, and ultimately when we do the CIP cycle, because we have to clean every piece of pipe and all of the separation units, and we need very high velocities. So I think I mentioned to you before, the base design when we started this process, everything was single use using these bags, including that. So when we did our initial testing of this when it was delivered, we found that when we were doing a CIP cycle, that basically the outlet connection of the bag was basically mechanically failing because the flow rate was too large. So we had to change the design and replace one of these mixers with the stainless steel tank. So this is something that we got 999 to do. It was basically an after order, if you like, once we started testing on the Hemoph itself, because the bags were failing.
Yeah.
Because the velocity was so large to feed all 3, or even to feed 1 loop. Because the original design basis actually was we cleaned each loop using each mixer. Yeah. But what we then found was the velocity and the mechanical shearing force on the outlet was too much for the bag itself, and the nozzle started coming away.
So the reality is, this isn't the first time you've turned this on.
No, this will be the 3rd time that we've actually turned this on.
So you're going through the problem as to be expected,
Yeah.
as Christina said, like anything in life. Once you connect it up, you've just got to find where the grey areas are. But
That is to say, we weren't expecting that we'd have a mechanical issue on the bag, right?
no.
So what we ended up, this cost us an additional probably 700 grand.
Yep.
To get a brand new 316L stainless steel tank and all of the connections, permanent connections to that, because that was unanticipated that the bags would not have the mechanical.
But you can see here, with all the connections, everything's connected.
I
Everything's
think you'll also see, Sean,
kicked in.
you'll see from the last time you were here, we've replaced the lagging to a much better clean room covering, because the one we had before, it wouldn't have, in my opinion, we wouldn't have passed TGA inspection. So we've replaced it now with a new PVC, GMP compliant lagging.
So it hasn't just been putting the clean rooms in, you've actually been installing this the whole way, finding problems along the way.
Correct.
To fix it, so when you've got the TGA,
Yep.
you're getting the big tick now. Just to reinforce,
And as you can
TGA...
see, all of this, right, was never envisaged.
No. But
Because the original basis was it would be this. Right?
But these plans have been shown to the TGA.
Oh, yes,
The adoptions, the changes.
Correct. 100%.
So the TGA has gone through it, and they had all the suggestions they had, you've adopted.
Correct.
So the risk of not getting TGA is minimal, because it's the 2nd time we're going to have GMP for a facility.
That is correct.
Because we've already had it for the cartridge set up. It's just gone from a V2 to a V8.
Yep.
What we'll do is we'll go through the rest of the facility now, Damien.
Okay.
But this is the money shot. This is what we've been waiting for.
This is the most expensive piece of kit that we have, right? This is worth about $5.5 million. And this is our fully automated filling machine. This basically takes the vials, we put in stoppers, we put in caps, and basically then we load in our vials. The feed bag will sit here, that will come from here.
So this is the other
So
side.
this is exactly the other side. So we basically will take out the feed bag, it sits under here. We then have a flow path that connects via here, that basically then goes through this alpha beta port. We have our needle, which goes through here into the filling chamber. And then from there, we'll basically fill the final vials. So when it comes out of here, it's not just stoppered, it's capped as well. So this does the filling, the stoppering, and the capping. So when we take it out of here, you can be in a warehouse because it's basically in its final form. You don't.
So the step we've seen where it gets fractionated, where the final processing happens to come into the fill and finish.
Correct.
Where we're at, and everything, as you can see, is wet.
So
Maybe step back a bit to get the whole picture.
We have Van RX coming here to do the final work on this in the next 2 weeks.
2 weeks, and then we're ready to go.
Yep.
So everything's...
This is kind of new since the last time you were here. This basically is a sterility test isolator. The reason we're doing that is that when we're verifying the sterility of here, we'll have to put in, biostrips, and so the idea is that we'll basically test them and stuff in here. So this gives you the same finish as you get in here, right? So this is a sterility test isolator. So that's basically going to be used for the sterility testing. So this is like a biosafety cabinet.
How much are one of these worth?
That is worth $350,000.
And we're paid for all this already?
It's all paid, yeah, absolutely. Yeah. All of the equipment's paid for. This is the first step in the post-viral filtration. Ultimately, what we're doing here is we've manufactured the product in the Hemoph. We've then gone through a viral filter.
Yes.
And then we then come into basically here for final formulation. So this is a very simple process. You can see here the bag, because again we're single use, right? So basically this mixer is connected up via flow path into the UFDF, which is this Cytiva Active Ready Flux. And then what we do basically is we then change out the buffer into what will be basically our final formulation buffer. So what this process does is that we connect up the product bag from the mixer. We basically process it through here, and we then exchange it with the required new buffer that is in our final formulation.
So how much can go through here each year?
Well, this is sized to do a batch a day. So this will process a minimum of 1 batch a day. In reality, it could probably do up to 2.
Yep, and how much is that in terms of throughput?
In terms of throughput, what we're talking about is, depending upon the starting concentration of IgG, but we would do between 12 to 1400 vials a day of hyperimmune.
Wow.
So, and then we've the ability, obviously, with the Van Rex that we have next door, with the actual filling machine, to do 2 batches a day.
So in terms of litres a year, that's 120,000 in the...
Correct, yeah. The Van Rex can do up to about 250.
So we could do train 2 as well? So
yeah, with just the one machine.
And so these will do 120,000 litres a year?
Yeah.
So these have just got to be plugged in, there's nothing really...
Yeah, it's interesting. When we start the process, we're starting off, as you know, with a batch size of between 300 and 350 litres of plasma. When we come to final formulation, our volume is down to about 40 litres.
Yeah.
That's obviously what then makes up the final product that we put through the filling machine.
So this product that would be in here would be anti-D, for example?
Anti-D, hepatitis B, could be rabies, tetanus, any of the hyperimmunes that we want to manufacture.
And this is the agreements we're looking at getting as soon as this plant's got TGA.
That is correct.
With one of the major fractionators, you'll be taking the plasma from the machine, which we've just seen. It goes into here, it goes into this machine here.
Yeah, so then we do the exchange, the buffer exchange.
Yep.
And then we put it into its final product bag. And then from there we transition. This is basically a pass-through. Yeah. So ultimately what happens is then that the product in its final bag goes into the pass-through hatch. We close it here, and then it's opened at the other side and brought in by the team that are doing the filling.
And all this is what grade clean, remember?
It's all grade C.
Grade C, so this is what, everything's finished, everything's done to get it working now. So
correct. All we need to do basically now is, as I mentioned to you, we'll be ordering plasma next week. So within 2 weeks, we hope the plasma should be delivered here. Then we'll actually, so we're at the minute, as you can see, there's only water in that bag, right?
Yes.
So obviously what we've been doing is just doing the testing, obviously using water as part of the qualification exercise because obviously all of our equipment, as you know, because we're pharmaceuticals, has to go through IQ, OQ, PQ. So we can do most of the IQ and the OQ just using water. And then obviously for PQ we need to start putting plasma through.
So you've done the water tests
Correct.
So this works with water. Okay.
Yeah, so this has been qualified through OQ.
So these are both approved?
These are both through approved OQ, operational qualification. The final step for for the PQ is obviously for us to start processing plasma.
And 2 weeks you've got the plasma coming?
Should be here we're ordering on Monday. We reckon it'll take about a week and a half to get here, a couple of days to clear customs. So we're hoping by the latest middle of May, plasma's here in the new freezer that you saw when we were walking in. And basically then we'll start looking to put plasma.
This is a finished facility, Damian. It can't be lost on everyone that's watching this video. We've put a lot of money, a lot of sweat. You've been remarkable in getting this thing to the next level, and we've actually got a plant. We've been finally waiting for years for this moment. We now have a plant that is on the path of producing.
Yeah, ultimately, you know, we've two major cleans to go, right? At the minute, we haven't put the HEPA filters into the clean rooms because they block easily if there's dirt, right? So what we want to do is the next thing for us will be a high-grade construction clean, and once that's complete, then we'll basically put the HEPA filters in and we do a pharma clean. As soon as we do the pharma clean, now everybody walking around here is not wearing what we're wearing today. They're wearing a full grade C.
So this is the last time we'll be able to do a video in this facility?
In these clothes?
Yeah.
Yeah, correct.
So we have to wear the hose.
And obviously that's the reason where you're in the overshoes and why you're in the overcoat is because this has been cleaned, but there'll be another deep clean again, and then we put in our HEPA filters, and then after that we do what's called the pharmaceutical grade clean, and once we do that, everybody's in here is in full plant uniform, and if you're in here, that means you're in your grade C bunny suit.
So if we were building a house, if you could just equate it, because everyone's got a house, you just put the curtains up. You've got it to that point. You've done the clean.
Yeah, you've done your first clean, right?
Yeah.
You've got off all your construction dust is done and dust. Then you want to do your next clean to move into the house, right?
Yeah. Explain what this is just here.
So basically, what we're doing is, remember I mentioned to you that we've brought in the new membrane manufacturing process known as LAP or LAMP, late activated membrane production. Basically, then what we've done is we're testing the new membrane in here, and what you see here before is the one behind you. You can see is our Hemoph HFO1, which is the piece of equipment that we use for all of our clinical trials. But in parallel to that, we've developed a smaller one, which is just like a single separation unit, which you can see on the table behind. So what we're basically doing is we're actually doing a Hemoph run. And again, what we're trying to do is just basically generate the additional data that proves with the new membranes, because the new membrane process, before it used to take us roughly about 16 hours to do a membrane. Now we do it in 30 minutes.
And it's automated.
It will be fully automated when we go into full commercial operation.
People have said that was a bottleneck of the business, and now it's clearly not.
No, the new manufacturing process with the LAP. Basically, what we'll end up doing is we'll end up having a single manufacturing line, probably U-shaped, which will almost look like a printing press if you think about it. Because ultimately, I've designed these facilities before. I did them, not a printing press, but a transdermal, which is a patch. So I've designed for Johnson & Johnson their facility that made fentanyl patches and made nicotine patches. So ultimately what we're trying to do, even though it's bigger than a patch, the design process is actually almost the same. It's a polymerization reaction that in this case what we're doing is again it gives us greater levels of assurity in the manufacturing process as well, is that we're replacing what used to be the old method, which was the polymerization reaction was catalyzed using two chemicals. We're now catalyzing this using basically ultraviolet radiation or light basically. So that's enabling us to have greater level of consistency in the manufacturing, practically zero failure rates, which is critical obviously when we want to do mass manufacturing, and the ability to basically almost remove the human being from the process. And obviously we all know in manufacturing that the greatest level of failure is basically human interaction.
So the reality is, David, this isn't the first test. You've got a much thinner.
This will be the third run we've done with the new membranes. Obviously, you don't ever want anything to be ran on an N of 1.
Yeah.
So ultimately, we're doing this run. This will be an N of 3, and obviously, as I mentioned to you before, all of the testing that we're seeing an enhancement in the productivity rate in terms of the throughput capacity of the membrane. We're seeing consistency in the manufacturing process, and we're obviously getting the purification requirements terms of purity of product that we need. So our business is based on three key tenets. One is capacity of process, two is yield, and the third one is product purity.
And I think the cool thing is with the yield and the purity, that puts us at the low point of the cost curve, which is where I want all of our investments to be. So we're very competitive. So the good thing is Aegros hasn't stopped with the you've got the V1, V2 and the V8, which gets us to 120,000 litres. Aegros hasn't stopped R&D. There are always improvements that Damian and his team are pushing forward with, and the constant innovation will keep Aegros at the forefront of the plasma fractionation game. So it hasn't just been a build of a facility, let's keep going. There's been innovation throughout this building process, which has really reduced the timing of the membranes and the throughput, which means more revenue potentially for shareholders in the future.
And reduced our cost of goods sold as well.
So reduce of cost again, that low point of the cost curve that we really want to see.
Yeah, that's why we can go into countries in Southeast Asia who are basically today starved of plasma-derived medicinal products, and be able to provide these guys with the source of medication they don't currently have, but at the same time still make higher gross margins for our product than CSL and Grifols are seeing selling into the first world.
The good thing is you're looking at saving millions of lives that currently don't have access to this technology, which is the good part of this investment, saving babies with the NED. And the reality is we've got the efficiencies to do this globally. This facility is just the start. That's one thing that we can't get lost on here in terms of when we're looking at valuations. We've got this facility going to revenue potentially in the next 3 to 4 months, depending on when TGA and the contracts are executed. But this is just the start. It is not the end. Aegros can grow significantly from here, which again is why we've invested. This technology is hugely scalable. You've got Virgin 1, V2 as a car engine, 1 cylinder, 2 cylinders, 8 cylinders. It's like solar panels. If you need more power, you have more panels. It's exactly the same here. The process works, and the efficiencies that Damian's team have created give us the revenue potential for the future.
Yeah, I think another important thing to recognise is that this is an industry that's almost 90 years old now.
World War II.
And it still has a CAGR, a compound annual growth rate between 8 and 10%. But the other thing that you need to really, really notice is that this is an industry that is constrained not by demand. This is an industry that is constrained by supply.
I'm aware when we met with the NHS, when Aegros was looking at potentially building a facility in the UK, the NHS was adamant when they saw that Aegros could do over 80%. They just signed up one of the major fractionators for a 40% yield. We give them double the supply, which again is a lot more products, and the hospitals don't have enough product. You're saying it's growing each year 8-10%. Yep. There's just not enough product out there, which is why this investment is what attracted us to it in the first place. And here we are on the verge of getting into production. And again, more and more innovation to keep us ahead of that curve.
Yeah, I mean, we will have the TGA in to audit this facility in less than 11 weeks. That's a thing to bear in mind here. So
fantastic.